This comet is 80 miles wide. For more than 1 million years, it has been falling towards the Sun. Trace its orbit backwards, past every known planet, to a region no telescope has ever seen. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Tonight, we point it at the invisible edge of our own solar system. Start at Earth, move past Neptune. Next comes the Kuiper Belt, the icy region that contains Pluto. Farther out, the Sun's wind finally ends. Cross that boundary and you enter interstellar space. Voyager 1 has crossed the heliopause, so it is traveling through interstellar space, but it has not reached the proposed Oort Cloud. On the wider map, Voyager has only passed the first boundary. NASA estimates that Voyager may need about 300 years to enter the cloud. It may need 30,000 years to pass beyond it. Crossing the heliopause was only the start of that journey. Keep following Voyager. The planets and the heliopause now sit behind it. The proposed cloud still lies ahead. The Oort Cloud is not a line beyond Pluto. It is a proposed region with a near side, a far side, and an enormous width. There is no photograph of this cloud. Its first map was drawn from motion. In 1950, Dutch astronomer Jan Oort studied the paths of long-period comets. Each visible comet carried a clue to where it had waited before falling towards the planets. The planets move around the Sun in one broad, flat plane. These comets do not. They arrive from above that plane, below it, and almost every angle between. Now trace those paths backwards. They do not return to one hidden planet or a flat ring. They spread around the Sun in 3 dimensions. Both clues point to the same answer: a distant store of comets surrounding the Sun. It explains the enormous orbits and the arrivals from every direction. We call that model the Oort Cloud. That evidence has a hard limit. No object has been detected in the proposed main cloud region. The cloud's shape remains an inference, not a photograph. The leading formation model begins in the young solar system. The giant planets were still rearranging the system. Icy bodies formed much closer to the Sun, among the giant planets. A close pass by Jupiter, Saturn, Uranus, or Neptune changed an object's speed. The planet's gravity then threw it onto a new orbit. The strongest kicks sent some bodies out of the solar system forever. Weaker kicks left others on stretched orbits that still belonged to the Sun. Those survivors became the raw material for the cloud. In one modern model, only about 5% of the scattered material remained bound and joined the Oort Cloud. Most of the original bodies did not. The cloud is the small surviving fraction of a much larger scattering. Far from the planets, the Milky Way and passing stars can reshape a comet's orbit. Their pull moves its closest approach away from the giant planets. The comet can then pass without being thrown out again. Those weak pulls come from different directions. Together, they tilt the surviving orbits onto many different planes. A swarm born near the planets slowly becomes a thick cloud around the Sun. One model estimates 700 to 800 billion cometary bodies, bright enough for that study to count. That is not a census of every object. It shows how much hidden material may be needed to explain the comets that reach us. The same outside gravity that helps preserve the cloud can also send a comet back towards the planets. The Milky Way is always pulling. A passing star adds a shorter, sharper tug. Either force can bend a distant comet's path back towards the Sun. We do not know what sent UN 271 back. We know only that it has been falling towards the Sun for more than 1 million years. Its full orbit lasts about 3 million years. That path cuts through the familiar planetary plane at almost a right angle. The motion fits a visitor from a surrounding cloud. Pedro Bernardinelli and Gary Bernstein found the comet in old dark energy survey images. The faint point had been recorded years earlier. Nobody knew it was moving until the images were compared. Hubble saw a bright coma, the cloud of gas and dust around the nucleus. It could not see the solid body directly. Astronomers removed the coma's light, then checked the result against radio measurements. That is how they reached 80 miles. In 2024, ALMA detected carbon monoxide gas escaping from the comet at more than 16 times Earth's distance from the Sun. The jets changed over 9 days. The comet was already active where sunlight is weak. This comet shows that a large body can return from extreme distances. Its modeled orbit gives us one path, but one path cannot reveal the full size or shape of its proposed source. So where does the solar system end? Not at one wall. Its gravitational edge spreads across a vast region where the Sun's pull slowly gives way to the galaxy. The heliopause marks where the Sun's wind gives way to interstellar space. Voyager has crossed that physical boundary, but the Sun's gravity continues far beyond it. Inside the Oort Cloud, the Sun still keeps each surviving comet in orbit, but that hold is weak. The Milky Way and passing stars can change the same orbit without taking the comet away immediately. The Sun is moving through the galaxy. Along the way, the Milky Way and passing stars keep changing these distant comet orbits. The edge changes with them. The Oort Cloud is part of that moving border. The predicted inner edge begins at least 2,000 times farther from the Sun than Earth. The possible outer edge may reach 100,000 times Earth's distance. These are broad model ranges. No spacecraft has crossed them. Astronomers begin with the long-period comets we can see. Then they estimate how often the galaxy should send one towards us. Change the assumed comet size or return rate, and the hidden total changes. That is why the estimates vary so widely. We have measured the messengers, not the reservoir itself. Their orbits point towards a distant surrounding source. The Oort Cloud is a strong inference built from arrivals, not a photograph taken in place. One star is already heading towards that region. GJ 710 is predicted to pass through the proposed cloud in roughly 1.34 million years. The lens does not blink. Subscribe. Next time, we pointed at GJ 710, the star predicted to pass through the proposed Oort Cloud